He has like a license on one of these. This says public domain. This says CC0 license. Which is what? Okay. Great. That's a good license. Does anyone know what float16 is mostly used for? That's pretty low precision. It's not really that low. I mean, it's more than 1 bit, right? If you have a 1-bit number, it's a lot more than that. Can you live in my apartment in Florida? I don't think the building will let you in. So like before Christmas, before I went on my vacation to Florida, they like dug a bunch of stuff up in the street over here to like do some cabling or pipes or something. And now they're digging it up again. So I guess they screwed it up and now they're trying to fix it. I don't know. It was like weeks back then. Now it's day 2 of construction noise right outside my window for probably no good reason. Is it expensive? It is pretty expensive. I did not, however, try very hard to price compare. I just said yes to the first company that said that they would move it. Because, like, it was 1 week's notice, sort of, when I actually decided. Actually, no. I talked to 2 companies. One of them was a less of a good service for my purposes, and it was less expensive, but I was like, okay, if that's my lower bound and it's going to cause a lot of inconvenience for me, then like I use that to bound like how much could I save by shopping this other thing around, and like, okay, a little bit, but is it really worth it? And I decided no, and I just went with it. Move stuff time to time. No, all my stuff is going in a big truck, except I'm keeping a small amount of company stuff here in this apartment right now that I will move out of later on. But all my personal stuff is going because I do not, as of the end of this month, I do not reside in California anymore. Pack all the sun. Oh, I ate all the sun chips. Don't worry about that. There ain't no sun chips left to pack. Look at all the rating people. Let's decide what of Fabian's code that we want to take. By the way, anyone who, let me paste the article text for anyone who wants to like read the background of what is going on. You can read that. Any plans about the compiler's release date? Well, look, I mean, I just compiled a whole video game. I mean, what else do you want than that? Do people think that I don't like visual scripting or something? Is that you guys are misinformed? You guys don't even know what you're talking about if you're trying to rile me up with that. So the joke's on you. I always say that visual scripting is better than shitty old-fashioned scripting languages. Like, that's what I say every time, guys. You got to do your research if you're going to try to, like, trigger me. Okay. So, last night I was kind of goofing around and I did a float32 to float16 port thing or conversion thing. It was not very serious. It did not handle all the edge cases in floating point. This article that I pasted the link to, which is also the link here, he goes through like what those are and talks about that. Although this is half to float, right, which is going, I mean, we sort of did both directions last night in a really sloppy way. This is sort of a more thought through, serious version of the same thing. And since he put this in public domain, it was like, okay, awesome. That's really good. Like, there's all sorts of crappy code in the world that you can get, but sometimes when there's really good code, that's good too. Okay, we're going to just copy pasta all this, but we're actually, we're not going to use most of it. Because he sort of did this exploratory thing where he went through different ways of solving the problem. And we're also going to remove these comments because we linked to them. Wait, this is float to half? We'll do this first. So we probably want this one and this one. And this approx thing I don't care about. Round to nearest even. Break ties to even. I didn't think that hard about rounding. I do not remember the rounding part of the floating point spec. What's my opinion on DEC 64 real number system? I don't know anything about it. I don't know anything about it. So if we want to give people a general one that's just like, this is the default thing, and if you want these other variants, you can go look at his original code and port those. It's either this or this, but I don't know. Well, or this, I mean, not the unoptimized one. What? Okay. Let me educate myself. Floating point rounding mode. 4 rounding modes. This is the default mode. Should be used unless there's a specific need for one of the others. So he's saying round to nearest even, which is like some extra elaboration on this, but okay. Let's just see. So we're not even going to use this union situation probably, because this has different ramifications in our language. So we're just going to go, and we might even rename these later. No, we'll just do it as we port. So we want to look at float to half fast 3 and then RT&E, and hopefully they're in the same order. Looks much shorter, yeah. Okay. Oh, okay, yeah. So I guess we just want this and then the SSEs. So let's try to look at if we could see what the difference is. This is quite a bit longer. Let's just start by porting the simpler one and getting it working. And that'll be, because a lot of this code is the same, right? Like it's just really down here that is different. That turns into this bigger thing. So we'll just start by this, and once we have this working, we can do the more elaborate one. And then we're going to delete the approxes. And we won't worry about the SSEs till later. Okay, and then, yeah, these approxes I don't really care about right now. The tables we don't care about because those are from the approximates, if I remember the code. For verification, we might make a separate test file, who knows. We're not going to worry about verification yet. Initially, we're just going to run things and make them look good. All right, so we're just going to port this single thing first. So we're going to say float All right. So, float32 infinity. I mean, I think we have a definition of that, but we might not want, like, that's in basic and we might not want to rely on that. So that's fine. So float16 infinity. In 32 bits. It's like, okay. Whoops. Okay. Sign mask. Eight oh 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 oh. Round mask. Let's just write it out. Why is that? Not FFF. 12 bits. I don't know why it's 12 bits. We'll leave that there. Shouldn't it be? No, because there's a knot here. You got to read the squiggle. The squiggle. It's important. Okay. So we're going to do that. Sign. XOR it. Okay, so if u is greater than or equal to like, if we're going to reuse these in multiple versions, we should just define them all at file scope anyway as constants, which will cut down, like these. Yeah. Anyway. Oh, man. Maybe I should do the union thing. For this. Let's see. Let's see. Let's try it this. So we're just going to put that in there, and then we're going to get the U. Hopefully this works. Hopefully we don't turn up a compiler bug. Okay, and he wants this to be a float. So that magic number, and then we do, see, we mask the round mask, we float multiply. See, this part kind of sucks. Okay. With all the O's and U's and F's, clearly I could have messed this up several times. Let's just see where it goes. So this magic, okay, let's do this the lazy bones way. We need to make a program that does this. Let's write this to, this is my goofy version that I was doing yesterday. All right. We're going to wipe that out. We're going to go main. We're going to import basic. We're going to import float16. By the way, we're going to go, let's just do this. Just make it easy on myself and not make a mistake. Obviously, 15 is, 4 bits. It's an F, but, it's offset. It's an odd number of bits. Whoops. Oh, I got to do the no check-in. All right. 7800. Yeah, so, whoops, we didn't want it to be U32, actually. We want it to be float32. 0780 0000. All right. Because, like, he had all these unions in here for, like, stuff that didn't need to be. I don't know. Anyway. It's all up, I don't know what you consider to be cleaner. I think if you want the fast version too, you just use the SSE one. Sign mask, round mask, blah, blah, blah. Okay. Let's do what we did in the other program. 4, 0, 2, 20, F, cast, float, it, FF is F times F plus F times 0.01, right? Half is float to half fast 3 of F print I don't know. Okay, This might be a case, either I goofed. Oh. This is a case where, you know, C will just do that cast for you and we are stricter. O. Same thing. Okay. Oh, you know what? Our print integer doesn't like type isas right now. For some reason when we try to print these. So we're going to cast that. That's kind of a mess. All right, so those look like numbers. They don't look right to me. They don't look right because the mantissa does not have any juice in it. Oh, because I put F and not FF. That's why. So it's probably right, actually. I just put the wrong number in. It's hard to compare the numbers because there's like different. I feel like the top digit ought to be the same. Always, shouldn't it? Because it's sign bit and then 5 bits. Oh no. Right, because in the bigger float number, because there's more exponent, it'll be right shifted. So we might be fine. You know, I think maybe we do the other half of the conversion and see how it comes out. Just like we did last night. All right, so let's go to his other file. Let's clear this part out. I'm going to go to Fabian's other file, which is and down here he's got like some testing code and stuff that we will enable, but again, not yet, because we just want it to like, first we want it to plausibly go back and forth in such a way that we can like eyeball it, right? And then we run the test on it. Okay, so he has this other file that goes the other way. And we're just going to put them both in the same file because, again, we're doing a subset of this code. Okay, so I think we want Fast 5, right? Because that was a really good movie. Will be slower if denormals. He spelled it wrong. Very slick and short, but will be slower if denormals act. I actually don't know if we expect denormals. Maybe we shouldn't do 5. Maybe we should do 4. Let's look at the difference between 4 and 5. There's 4. There's 5. I mean, 5 is smaller. But like, he says it's not really that much faster. So we're going to go 4. I guess. Because of that potentially bad behavior that he mentions. Do we have built-in testing support? Yes, we do. The way it works is you compile your test, and that ability to compile your test is built into the compiler. And then you run your test, and the compiler generated the thing that you run. So it works pretty well, really. Wait, does he use these tables? No, just for the first one. What's her job? Tables. Tables. So this time he's like using these members. All right. This is what we want to port here. Being able to mark functions as test and have the compiler pick them up and run with a nice report of the results. You can do that if you want. You certainly can do that, yes. All right. I assume we're going to want to do some maneuvering again. Are these the same magics? No, that's a different magic. These are different numbers. So let's look at the H, because he wanted to do U's and H's. This is the only H. Oh no, down here. But we only ever H.U. Do we O.F ever? Okay, there's a magic.F here. That's really the only .Fs. Oh, but we also O.F. All right. So we're gonna do the union. Using O union U32 F float32. Okay. And then H is going to stay H. And so O.U is just going to be U. It's H. Exp is shifted exp and U. U plus equals that. Let's do these. The magic, okay. Let's do our same thing down here. Let's not even do any of this for now, so we can compile, because we left this in a state of chaos. Oh, you know what? One 13, right? Boom. Okay. So u plus equals that, u plus equals that. And then f minus equals magic. I do believe it is magic. And then u or equals sign bit. Return f. Great. Have to float fast 4. So we bring back our loop and let's just say the input is this. Output is have to float fast 4 of half. Output is whatever. Output fast 3. Oh, because I didn't even do this. Okay. I don't know why it's saying that. That's weird. Dude, yeah, we have a... Houston, we have a problem. The compiler is unhappy. We're going to have to figure that out, but not yet. I don't want a rat hole on this. So what we're going to do is put this input that is somehow hosing the compiler down here. I don't know why. That's weird. Like, we haven't had problems like that in a long time. All right. So now we're just going to keep sliding the window. Okay. Okay. It might literally be this line. What is so funny about that line? All right. Let's do this. I think it's just that this type is a declaration stuff is new. Weird. I really... Okay. Okay. It is accepting this. So we're going to have to figure that out later. Okay, now maybe maybe this is just super hosed. Like, we don't know. Maybe I made a simple mistake here. Maybe whatever was confusing the compiler about this is also breaking this. Or maybe, yeah, let's just say, let's see if the union's confusing it. Okay, interestingly, U seems to be 0 sometimes and not 0 other times. So this indicates to us there are two problems. Two problems. Because why is it 0? Whoops. Duh. Or maybe this is something that looks like 0, but I don't... Guys, this is going real bad all of a sudden. I have to float fast 4. Oh, you know, let's actually put this in hex. That might clarify some things. Okay. It's not that surprising to me if that looks like 0, because that might actually be 0. Now, clearly, it shouldn't be 0 in these other cases. So, like, something is horrendously wrong earlier up the function. Okay, first of all, yeah, when I did these casts, they're the wrong type. Okay. There we go. This is sort of what we expect to see. Inputs, outputs, they're pretty close. All right, let me delete this. So we still have a compiler bug we have to look at. But it's pretty okay. I don't even think we need these parens here, right? Yeah. So okay, so we're still good without all the funny business. Let's bubble that out there. Looks fine. Okay, so this is all actually, I don't know why I got confused in the middle. This is really how I would normally write this anyway. Because so this input number, this is 16 bits. So after you mask it, it's 16 bits. We don't do this weird int promotion secret thing that C does. So if you left shift this, it'll shift to 0. So you would want to cast it on the outside anyway. Me casting it on the inside was because I thought this was crashing the compiler, but it wasn't. And at this point, I'm not sure what was, honestly. But we copied the exact text of this below, so we can hunt that down later. Okay. So we've got the ability to go both directions. And I feel like we're going to go with the fast 4 one. We could port the fast 5 one someday in the future if we feel like we want the shorter code. But what he has to say about the subnormal handling makes me nervous. So there's 2 SSE versions. We're not going to worry about these at all for now. That looks like a spiffier version, probably. Spiffier, but less understandable. Okay. Now this was the non-correctly rounding dude. Okay, I messed some stuff up here. I already see some stuff I messed up. This doesn't make sense because it doesn't output to this. I think this was O.U. O.U equals F. Yeah, okay. So this is just O. So we would have flunked that. And let's double check the other clause. These are FUs, and it only writes to O at the bottom. Yeah. Okay, so, I mean, honestly, if I were just doing this for internal use, I would just start using this right away. But we're gonna actually ship this to the people in the next drop. Which probably happens tonight. So we'll say, I guess we want the good rounding, though. Even for our own purposes, we want the good rounding. So we'll port that. We might... I feel like I'm going to want to get dinner or something, or take a stream break, but at some point, we could do an assembly version of all these SSEs. Like, I still have hardly done any assembly in this language, so it'll be fun to do this. But before we do that, I think we want to get the rounding mode in. We want to get the test enabled, right? So we can run the test, and then we know if we break it with the assembly. Personally would still use a bounding box and integer coordinates within this box. Yeah, so here's the deal. Here's what we decided. I can fill you in because I had similar conversations with Jeff and Casey. How many days left in California? 6 days from now, I will be getting on the plane. 5 days from now, my stuff will be gone. So I was talking to Jeff and Casey, and Casey, who has done a bunch of curve fitting animation compression, was like, it's really not the right thing if you want to have a lot of detail. And they both convinced me that some kind of entropy coding scheme would be better, right? So, more like kind of like zipping the file, except, in-memory compression and decompression. And so when you queue up an animation to play, you just do some relatively cheap decompression on it, and then it kind of doesn't matter how much detail there is, right? And so we like that. So they convinced me. So that is the plan. And so this float16 thing I'm doing right now is sort of a temporary, midterm thing, right? Long term. So if you're going to do an entropy coding like that, it's probably 2 steps. One, you basically, how do I describe it? You basically convert your array of values to something as small as possible, right? And so like if you have a bunch of 3D vectors, I mean as small in magnitude or as predictable in magnitude as possible. So like if you have a predictor, let's say, right? Like, hey, based on the first 2 values, right? We just delta them, and then we keep guessing that delta every time. And then instead of storing the value, you store the difference between your prediction and that value, right? That will generally be a lot smaller than the value itself, right? And possibly more compressible, usually more compressible, right? And then once you've done that, you apply the entropy coding part, which is just like, classifying symbols by frequency and all these things that you can read about on the internet. So, that's going to be the plan. And so it's not necessarily likely that we're going to do this float16 stuff in the final animation format, but I was feeling like doing it today because I was like, hey, this will be fun. We could ship it to the people. And like I could think of other places in the game where I would store float16s if it were easy. I actually wonder... Guys, I forgot to check this. We might fucking already have this code in our game for all I know. I didn't think about it. Okay, we have a half, and it comes from this Fox toolkit, which Fabian's comments were saying was not as accurate. Because I was thinking we probably have that because we put those into shader variables that we upload to the GPU. So we are currently using Fox toolkit. Maybe we could switch to this later. I don't know. How bad would it be? Do the animations get very artifact jumpy? Well, it depends. Depends on if you compress them in a way that loses detail or not, right? Favorite classic shooter game is Counter-Strike. Counter-Strike, bro. Okay. Now we have come to the part of the stream where we vote on tea. And the problem is we have 2 tea flavors from the last set. And then they mailed me 4 more. Kaylee from Firefly has been flying around to all the planets and getting all the tea. So we're going to make a poll. I think Twitch polls let me put 6 things, right? Let's find out. Manage a poll. New poll. Wait, it's only 5? It doesn't let me add more than 5. This is tragic. Okay, I'm going to close my eyes and shuffle them. And I'm going to remove one of them. How does use straw poll? But then that's not like integrated. All right. Out of the running is Classic Laoshan Black, which is sad because I could really use some caffeine right now. Okay. Here we go. All right, 3-minute poll. Here we go. You notice there's a rooibos tea here. And as I was typing it, I saw apple cider rooibos. And I was like, why doesn't Roblox sponsor some tea? And then you could have Roblox tea. Right? Toss that mistletoe in the trash. Well, you can certainly vote against it. We could actually show what they look like. Okay, mistletoe, apple cider rooibos, juniper tonic, citron mint black, and majestic Earl Grey. Okay. So let's get some of the testing code going. Okay. This crashes the compiler. Why? Okay. It doesn't crash. It infinite loops the compiler. It's very weird. Okay. So I don't think this uses these FP16, FP32 structs. Oh, it uses the .use. Okay, so this loop compares all these implementations to each other. We're only doing one, so this isn't going to really help us. This tests SSE versus non. That's also not going to help us because we don't have SSE. All right, you know what? Literally none of that helps us right now. So we're just going to claim that it works. Which might not be a very prudent route. Well, we could just try using this in the game and seeing what happens. Majestic Earl Grey won the poll. Let me see the results, though. I want to know how close it was. You know, people are not into the mistletoe. All right. Thank you for picking the Majestic Earl Grey. It'll have some caffeine for me. Let's try it out. It smells good. All right, let me get the key one back. Okay, to translate the animations into a latent space, I don't know what that means. I don't know what that means. Now, since we have this Fox Toolkit stuff in the game, honestly, I should just use that. Maybe. Just to minimize code footprint, right? Because the alternative is to use this for everything, which might be faster. But that's like a whole little project of making sure nothing breaks and whatever. Where am I getting the teas from? Kaylee from Firefly sends them to me. How much faster? Not clear. Not clear. But it's probably faster. It's especially faster because we could benchmark it. We could look at what the Fox Toolkit code looks like. It's table driven. Wait, what about the other direction? Yeah, this doesn't look as good. Who calls this? Literally nobody. Okay, wait. When I said we're using this Fox Toolkit, I may have gotten ahead of myself. That might be something that someone added speculatively because they thought that we would use it eventually, and that never happened. Like maybe we just don't upload halves to the shaders right now. That seems plausible. Are we even compiling this file? Like we're literally not compiling the file. If I delete it, what happens? If I delete it, does it not bleed? Okay, literally nobody was using that. GG's. Okay, so what we gonna do now is, I'm torn between actually using this in the animation and fixing the compiler bug. I kind of want to fix the compiler bug. Let's do that because we're about quality here at Compiler Company Industries Incorporated, right? Right. Okay, so our deal was this thing is bad news, right? Okay, what is we're probably infinite looping on something. But what? Dude, what? Visual Studio has eaten itself. I need to somehow find the project window so I can do anything. Does anyone know how I find the project window? Like there are literally 3 lists of windows. Is it? There we go. Look how fast all those drew in from top to bottom. It was amazing. Okay, this is fine. Now we are infinite looping. Now we break all. Check that types match. Okay, hold on. Why are we stack check? Is unhardened literal. Let's see. Input. It's a cast. Oh, yeah. Okay, wait. Where are we calling this from? Yep, it's in the type variant handling, right? If it's an unhardened literal, if we see a cast, it is not unhardened. So how did we get this? Okay, so we say no, that's fine. What are we type checking? Nope, 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 nope. The and. The and on line 706. So it doesn't, maybe it's the fact that there's a cast on the right there is confusing it somehow. Okay, it's not an unhardened literal. Silent check is, however, true. Okay, this is bad because we shouldn't get down here. Okay, the weird thing, we don't have a switchable expression given. Why not? Because we're calling from here and we null it out. It could have been Fabian Sanglard, guys, or Fabian Sanglard. There are multiple Fabians who do programming on games and graphics. Okay. How long do I let this Earl Grey tea steep? So what's happening is we're doing a type check. We see that our type on the left is a variant, right? Which is what we're defining. That's this. And then the type on the right is actually the same variant. But so we remove the variant type. Wait. We're not, okay, wait. Wanted variant of cursor equals wanted. This is bad. We deleted this. It's a copy pasta missing a line. Okay, that's a different problem. That's shift not understanding variance, but we solve the infinite loop so we can tell the people, oh, we've got so much value. We're going to have to deliver value to the people tonight. Look at the value. Oh my goodness. Okay. Okay, I'm going to pour the tea. I'm really hungry too, guys. I just got to put it out there. I have hunger. It's like Sinistar. I hunger. All right. This tea's good. It's a little, I hate to say this about tea runners, but some of their tea sometimes seems a little old, and this is one of them. Or maybe it's just not that potent of a tea. And it's got kind of a little bit of a flowery thing to it. It's a little bit like, so now it says, by the way, we make fun of the Global Tea Championship winner third places and stuff. This one says Global Tea Championship winner first place, best before July 2023. So maybe this is just how it is. But you can see in here, I don't know how well you can see this, but can you see that some of these are like blue? It's like there's a little bit of blueness in there. That's why it's Earl Grey, right? You can taste it. You can taste the blue. What are my thoughts on time attack mechanics? I think people should leave time alone, because if you break time, our universe is in trouble. Okay, let's fix this. Left argument of a shift operation. That was very loud. I actually don't know what the rules should be with regard to allowing arbitrary. We're just going to let you treat these like an integer right now. Whoops, like an integer right now. And we're going to see. Okay, so now that's a vanilla fix of the kind that we already fixed in the other one. So that's great. Let's run the tests on the compiler, make sure we didn't break nothing. Not x46. Fixed bit shift operations, not liking type variance as inputs. Saying writing and loading is weird. Okay. This is great. We will commit these. And you know what, guys? I'm just sort of feeling like I want to be offline. So I think we might end the stream here and raid somebody. There's definitely more to do. This has been a short stream. It's just my brain is in slow mode today. And so rather than like trying to keep energy up and entertain the people who are ravenous for things to happen, I think I just stay in slow mode today. And we can do a stream when I'm not in slow mode. Add modules, float16. Oh, people have been working on the compiler. Dang, dude. There's even more value. Look at that. If I feel more like fast mode, we'll do a delivering value to the people stream tonight. But I might just push the button to deliver the value to the people because, I mean, come on, guys. Oh, my float16 has no check-ins. Yeah, that was just to make us double check that. That was just to make me define magic. That was just that. All right. Okay, let's see who we can send you to, though. Who is doing interesting programming on the software and game development channel? Building a crypto-based creator platform. Oh, he's got the crypto viewers. Playtesting your games. Hot code swapping part 2. Meal action. Oh, Jessica Mack is back on. Let's do that. It's been months. All right. Thanks, everybody, and I'll see you later on.